All right, so let's talk domain. For the most part, to this point, we've discussed two different kinds of functions where we really need to be concerned about a restricted domain. The first is a rational function. So a rational function, remember, a rational number is a fraction, an integer over an integer. So a rational function is a polynomial over a polynomial. So since we're dealing with a fraction and a polynomial in the denominator, so an example would be something like, let's say, f of x is equal to x squared plus 14x plus 48 all over x squared minus 6x plus 5. So really, we have to exclude from the domain any x values that will make the denominator 0. So when we're looking for the domain, we need to consider what can't x be. All right, so in order to determine what's going to make the denominator 0, I need to factor this, right? So this is going to factor, the denominator will factor to 2 sets of parentheses. Again, kind of reversing FOIL. I know x times x gives me x squared. And now I need to think about what two numbers multiply to 5, but add to a -6. So that would be -1 and -5. So now I can clearly see that x can't be 1 and x can't be 5, right? Because if it were 1, then we would have 0 here, and 0 times anything is 0, so I'd be dividing by 0. Likewise, if x was 5, I'd be dividing by 0. So these are the two numbers I want to exclude from the domain. So the domain is basically everything else. Most of the time, you're going to be asked to express the domain in interval notation. So I think it's helpful to just jot down a quick graph of it. Let's see, 1 would be to the left of 5. So it can't be 1 or 5, but really the domain is absolutely everything else. So in interval notation, this would be from -infinity to 1, or from 1 to 5, union 5 to infinity. So there's my domain. The other type of function that has a restricted domain that we've talked about so far are radical functions. So radical functions would be, something like f of x is equal to the square root of x plus 2. So basically, when we're looking at a square root or any even root, you can't take the even root of a negative number, right? So can't take the even root of a negative number. Okay, so basically what I want to think about is this number, x plus 2, has to be greater than or equal to 0. I can take the even root of 0, right? The square root of 0 is 0. So that's what I do to determine the domain. X plus 2 has to be greater than or equal to 0. So solving that inequality, I have x is greater than or equal to -2. So this is basically my domain. These are the x values that make sense for this particular function. If x was smaller than -2, say -3, we'd have a negative number under the radical, and we can't have that. So in interval notation, again, if you are ever stuck with interval notation, just graph the solution set, or the domain in this case. So it would be numbers greater than 2. That means I'm including 2, greater than or equal to -2, and to the right. So my interval notation is -2 to infinity. So that is my domain in interval notation. Now, sometimes a trick kind of question is if you're looking at a function that's an odd root. So like, let's say it was, the cube root of x plus 2. You can take the cube root of a negative number. So this is sometimes seen as a trick question. If the index of the radical is odd, again, you can take the odd root of a negative number. So the domain is all real numbers here. There's nothing that x can't be. It's kind of a trick. All right, so now the trickier domain questions are when you put these two things together. So when you look at a rational function that involves a radical, so something like the square root of, we'll say 3 plus x over negative 5 plus 3x. Okay, so now we have both things to consider, and we have to really think about what makes sense in terms of x. So I do this in steps. For one, consider the radical. The radical is in the numerator, which means it can be 0, right? So basically I need to consider that 3 plus x has to be greater than, and it can also be 0. So greater than or equal to 0. So for 1, x has to be greater than or equal to negative 3. So that's one thing I know. Now when I consider the denominator, so the denominator can't be 0, right? So negative 5 plus 3x can't be 0. So let's see, what x value will make it 0? If we solve, 3x can't be 5, so x can't be 5 over 3. Okay, so that's my second condition. So really, both of these things have to be met. I think it's really a lot easier to graph this before you come up with your final answer, your final domain. So if I take a number line and plot the important points here, so negative 3 and 5/3. Negative 3 is somewhere to the left of 5/3. Okay, so now let's think about this. So x is greater than or equal to negative 3. Okay, so that means I'm including 3, so I'm going to close circle that, and then that would be to the right. And now my second condition is x can't be 5/3. So I have to exclude that number from the domain. So the domain is basically everything else. So my domain will be, including negative 3 to 5/3, but I have to exclude 5/3. And then we pick up on the other side of 5/3 and go on to infinity. That's round, whether it looks like it or not. The intent there is that that's a round parenthesis. So that's the best way to think about those. Let's do one more. Let's say we have f of x is equal to x plus 2 over the square root of x minus 6. Okay, so what makes this one a little bit different? Well, the square root is in the denominator. So I'm going to consider these things. For one, the two things that I really need to think about is I can't divide by 0. And I can't take the square root of a negative number, right? So those are the two things I have to look out for. All right, the numerator can be anything. The numerator can be positive, the numerator can be negative, the numerator can be 0. I don't have to do anything with the x plus 2. Everything I'm going to consider is here in the denominator. So for one, because of the square root, x minus 6 has to be positive, right? And because it's in the denominator, it can't be 0. So I'm going to leave off the or equal to here. It has to be strictly greater than 0. So that means x has to be strictly greater than 6. And that's it. That's the only condition. X has to be strictly greater than 6. X can't be 6 because then I'd have a 0 in the denominator. And X can't be smaller than 6 because then I'd be taking the square root of a negative number. So my domain is just from 6 to infinity, excluding 6.